All right, we're back. This is MAP4C day 26, part 2. We're looking at a calculator and we're about to hopefully get it to generate a line of best fit. We entered the data in the lists and now we're going to set up the plot. So we've done this, now we're going to do the second part, which is setting up the plot. So it says second function y equals. Second function y equals is the stat plot. You see it there in yellow. And you see that we can actually put up to 3 plots on. They're all turned off right now. You'll want to select one, and then we're going to make some changes to plot on. And we want it to be a scatter plot, but notice that we can do other types of graphs, one variable type graphs, a histogram, something like that. And list 1 has got our x's, and list 2 has got our y's, so this all looks good, and it's going to put a little square dot there. That looks okay, so we've done that step. Now graph the scatter plot. Notice that it's asked us just to hit zoom 9. So zoom sets up the window automatically. So zoom 9 is zoom stat. So it actually, the calculator looks at our data and picks nice window settings. So I'm going to hit zoom 9. And there it is, and there's my outlier. Notice that if we wanted to fix the window settings, because this isn't quite the same settings we had, because the outlier was down low, but not as low as that. Right? So if we wanted to, for instance, go all the way down to 0, we could put a 0 in there for x min. We wanted it to go down to 0 for the score, the output, the dependent variable, the y-axis. That would be 0, but I think it's okay. We'll go back to the graph, and so we could put our own window settings in there if we want to. Linear regression. Linear regression is the process that the calculator uses to get the line of best fit, and it describes how to do it. We hit stat, and instead of, remember, stat 1 was to get to the list, but I'm going to hit stat and then go over to the calc menu. And then there's a bunch of stuff in here, but it says now select for linreg. Linreg stands for linear regression. So I'm going to select that. I can select it by pressing enter, or like it says here, you pick 4, like this. And then it says it's waiting for us to put in list 1 and list 2 here. I'm going to move my calculator over here just so we can see. This is the screen that we're after, and notice it wants us to tell the calculator where to get our data from, where our x's and where our y's are, and the L1 are above the 1 and the 2. You see that? So yellow button, and then gets us to the yellow selections, and then a comma, list 2. And the Y1 business here is pretty neat. What this will do is this will copy the process, the linear regression process, and then graph the line of best fit automatically for us. So it says now we want to put the Y1 character in this last bit here after the second comma. There's the second comma. This last bit here will give us the Y1 character. So I'm going to hit bars. Then I'm going to go over to Y bars, and then I'm going to hit 1, 1, 1, and then 1, and then you see how the Y1 goes there. And then it says press enter, run the command. This is a command we're going to put into the calculator. That's what it looks like now. I press enter, it waits for a bit, and then it shoots out a whole bunch of junk here, a whole bunch of stuff. And we're going to come back to that, but let's look at the graph. Let's see, where can I put this so we can actually see what's going on. It says to graph, hit graph. And there's the line of best fit. Our line of best fit, what's funny, is actually, it looks like it's going downhill, right? Because of that outlier. We include the outlier, it's going downhill. Now, is there anything more on this page? Oh, the equation of the line of best fit with the outlier included is, well, let's get back to our calculator. And if I wanted to to get this equation, there's a couple of ways to do it. I could just hit second mode to quit, and so I could look at these values. Well, the R values we'll talk about later, but y equals ax plus b. A is negative 0.13 and b is 79, almost. I guess we could round it to 80. And then I could write that down. Y equals negative 0.13x plus 80. A second way I could have got that equation is when I'm looking at the graph, if I press trace, and there I am a spider, I'm on the plot. So if I go back and forth, I'm going to jump from point to point on the plot. But if I wanted to jump onto the line, if I go and jump onto the line here, let's see, where am I? I don't see me. There I am. Now this one, the way the calculator is set up doesn't have the equation, but I could actually show the equation. Press second format there, and then I'm going to put on expression on, hit the graph, and then if I press trace, it'll show me, oh, what equation's that? Oh, there's the equation, and then there's the equation of the line of best fit with all the decimal places, unfortunately. Okay. The second part is it's asking us to find the equation of the line of best fit with the outlier excluded. So we want to go back and do all of this stuff again, except for to leave out that one point. Well, what's nice is the calculator remembers the data that we put in. So if I press stat 1, and all I have to do is go down and delete that one piece of data. I will have to do some of the steps again, delete the one piece of data, and then I'm going to do set up the plot. That's already set up. Graph the scatter plot. I'm actually going to do the linear regression step first. So here we go. I'll get that out of the way. I'm going to go stat, calc. I could hit 4. I'm going to select 4. There's my old line of best fit. And I'm going to put my L1, comma, L2, comma, vars, y vars 1, 1, and then there's the same command. Run it again, and I get my new line of best fit, 1.22 or 1.23, I guess, and my b value is 66.5. So 1.22 y equals 1.22x plus, what was that again? 66.5, 66.5. And that's with the outlier excluded. And notice that how close that was to our, well, it was pretty close, 1.22 plus 66, but this one is the best one with the outlier excluded. Okay, what else do we have to talk about? The TI83 has a built-in way to tell us how good the linear model fits the data. We must turn this setting on, though. So, and these steps, if you don't have to do this every time. Once you turn on the calculator, you do this once, and then you won't have to do it again until you turn on the calculator again. So my calculator, I'm going to hit second, 0, and then this is the catalog of commands, and I'm looking for a command called diagnostic on, and I'm going to actually run that command, diagnostic on, press enter, and now this thing is turned on, this diagnostic on, and then when I run my linear regression, and I'm going to do this again real quick, in fact, my diagnostics were turned on already on this calculator somehow, for some reason, and yours might have been as well. Press enter. Whoops, what did I do? What did I do? What did I do? Oh, I didn't select in reg. I select this first one, which is wrong. I selected 1 when I should have selected 4. Okay, that'll be better. And see these two other values in here. This R value is called the correlation coefficient. And the correlation coefficient is a measure about how strong the line represents our data. It's a mathematical measure, the strength of a correlation. If R is close to 1, which this one is, it's a strong positive correlation. If R was negative, it's a strong negative correlation, so it's going downhill. If R is close to 0, there is no relationship, or at least a very weak one. And this R value from the calculator will allow us to tell us whether it's a good model or not. And this one is, isn't it? Okay. And hopefully you'll have some success in class working on the graphing calculators. Remember, you'll have a graphing calculator for this test and also for the exam. So practice up.